Hello and welcome. Today, we're going to open up the Modern Developer's Toolkit. We're talking about the essential software that powers pretty much everything you use, from your weather app to your social media feed. Let's dive right in.
Have you ever stopped to wonder how that actually works? You pop open an app and bam, all the live up-to-the-second data is just there. It feels like magic, right? Well, it's not magic, but it is a brilliant set of tools all working together perfectly behind the scenes.
So here's what we're going to do. We're going to follow the journey of building an app from the ground up. And along the way, we'll pull back the curtain and uncover this powerful, invisible toolkit that makes the modern digital world tick.
Okay, first things first. Any conversation needs a common language. And for the millions of software systems talking to each other across the internet every single second, that language has to be incredibly fast, super efficient, and of course, universally understood.
Just look at the difference here. On the left, you've got the old way of doing things, XML. See all those heavy, repetitive tags? Now look at the right. That's its successor, JSON. It is clean, it's lightweight, and it gets straight to the point. And this isn't just about looking prettier. This is all about speed.
So why did the whole world switch to JSON? Well, for starters, less text means less data to send, which is absolutely critical for fast-loading mobile apps. And get this, JSON is native to JavaScript, the language of every single web browser, so it just works instantly. And finally, for the developers in the back, it maps perfectly to data structures like Python dictionaries, making life easier for everyone.
All right, so we've got our language, JSON. But, a language is useless if there's no way to actually deliver the message. And that brings us to the next crucial tool in our kit, the API. Think of an API as a really well-defined contract, or maybe a menu at a restaurant. It's a set of rules that allows one app to ask for services or data from another, without needing to know any of the messy details of how that other system is actually built. A great way to wrap your head around this is the doctor-patient analogy. Your app is the client. That's the patient who needs some information. It goes to the server. That's the doctor, the one who has all the knowledge. You don't just wander in, you go to a specific department, like cardiology or radiology. That's the endpoint. And what you get back is the response, which is like the diagnosis or the prescription you asked for.
And sticking with that analogy, there are really 4 main things you can ask the doctor to do. A GET request is the most common, you're just asking for your test results. A POST is when you're a new patient, filling out your forms and creating new information. A PUT is when you need to update your contact info. And delete, well, that one's pretty self-explanatory, you're getting rid of old info.
Okay, success. Our app is talking to the server and it's getting data. But what happens if the server sends back a massive amount of it? We're talking millions of records. If we're not careful, our shiny new app is just gonna crash.
This is a classic problem. The first approach, eager loading, is like trying to download an entire library's worth of books all at once. You'll run out of space, or in this case, memory, almost instantly. The smarter way is lazy evaluation. This is like checking out one book at a time, reading it, and then going back for the next one. It's incredibly efficient.
And the magic tool that makes this lazy approach possible is called a generator. The secret sauce is that yield keyword. Instead of returning a gigantic list of 10 million items, a generator function yields just one item, hits pause, and waits for your app to say, okay, I'm ready for the next one. This keeps memory usage super low and totally constant, no matter how big the dataset is.
All right, our data pipeline is looking really solid. We're getting data, we're handling it efficiently. But now, let's turn the spotlight inward, onto the code that we actually write. As our app gets bigger, how do we add new features without turning our code into a tangled, unreadable mess?
Every great piece of code starts out like this. Clean, simple, just a beautiful little function that does one job and does it perfectly. It's easy to read, easy to understand, it's a work of art.
But then reality hits. We realize we need to add some logging. Or maybe we want to time how long the function takes to run. And suddenly, our once elegant function is bloated with all this extra code, and the original core logic, the whole point of the function, is buried. It's a mess.
And this is where decorators come in to save the day. A decorator is basically a function that wraps around our original function, adding extra behavior without ever touching the original code. You literally just add one little line, like @timer, right above your function, and boom, you've added new powers while keeping your core logic totally clean. It's so cool.
Okay, we're in the home stretch. Our app is getting sophisticated.
The code is clean, it's efficient, but is it strong? Is it reliable? The next tool in our kit is all about professional quality control, making sure our app works exactly as we expect every single time.
You know, this quote from the source material absolutely nails it. Writing automated tests isn't some optional extra you do if you have time. It is the foundation of building robust, dependable software. Frankly, it's what separates the amateurs from the professionals. At the very heart of almost every test is this simple statement: assert. Think of it as your own personal detective. It just makes a simple check. Is this condition true? Does this value equal that one? If the answer is no, the test fails immediately and points a giant flashing arrow right at the source of the bug.
And for more complex situations, we have fixtures. These are an absolute game changer. Imagine you need a temporary database or a logged-in user to run a test. A fixture sets all of that up for you before the test starts and then automatically cleans up the mess when it's done. This means every test starts from a perfectly clean, predictable state. It's amazing.
So let's take a step back. We've gathered all the tools. We can speak the web's universal language, we can communicate with other systems, we can handle massive amounts of data efficiently, we can write clean code, and we can guarantee it's all reliable. There's only one step left to complete the journey.
And now for the final awesome twist. We complete the journey by becoming a data source ourselves. With a modern framework like Fast API, we can take our entire application and, in just a few lines of code, wrap it in its own API for the world to use. We've totally flipped the script. We're no longer just the patient asking for data. We are now the doctor providing it.
So there you have it. From JSON and APIs to generators, decorators, and automated testing, that's the core of the modern developer's toolkit. These are the building blocks of the digital world around us. So the only real question left is, what are you going to build with it?